All right, guys, we are going to talk about Unit 6.8, which is solar energy. And so you need to be able to describe how solar energy is used to generate power. So that's both active and passive energy systems, as well as photovoltaic cells. And then you also need to be able to describe the effects of the use of solar energy on the environment. So positives and negatives in terms of environmental consequences for solar energy. So let's first talk about this active versus passive solar energy distinction. We talked about this a little bit in class, but passive solar is basically we're not using any mechanical or electrical equipment. We're simply absorbing or blocking out heat from the sun depending on the time of year and what we're looking to do. So it might be that we're going to use the sun's energy to cook food in a solar oven, or it might be that we're going to try to heat or cool our home using building design. So in the warmer months, we're going to try to block out the sun with our building design. And then in the cooler months, to allow the sunlight in and to be absorbed into building materials during those colder months. So some of the ways that we can accomplish this in both directions in terms of warming it up or cooling it down is through the use of double paned windows, making sure that our windows are southern facing and that they have roof overhangs to allow for the blockage of sunlight during the summer months. That we are using basically those conservation landscaping techniques. So we're using deciduous shade trees near our windows so that in the summer it's shading and in the winter the sunlight is able to pass through. Using skylights to decrease electricity usage, and then using building materials, dark colored building materials that are going to absorb sunlight in flooring. So active solar is kind of the opposite of this in that we're using mechanized equipment, mechanical or electrical, to capture the sun's energy. So these could be solar water heaters. This could be concentrated solar thermal energy, which is like solar energy on a solar farm level, or this could be the use of what we refer to as solar panels, those PV cells. So a solar water heater is going to capture, and here's a picture here of this solar water heater. So there's a liquid in here on this panel on the roof, and then the sun's energy is going to absorb into that water, and you're going to use that water to heat your hot water. So a household hot water heater could be used from this active solar heating on the roof. This is a passive solar design. Notice here that in the winter, the sun is lower in the sky, so it can get into those windows and it would go through this tree, because in the winter it wouldn't have those leaves on it. Whereas in the summer, we've built this overhang here, and so it's blocking the sun's rays now that the sun is higher in the sky in the summertime. There will be these double paned windows to either to not let heat escape out, and then thick walls and flooring that are going to absorb the sun's energy. All right. So a little bit more about those photovoltaic cells, those PV cells, the stuff that we have on the roof of the pool, on the school roof, in our solar field. So those solar panels contain a semiconductor, and the biggest thing that you need to know about semiconductors is, or that solar panels, is that they're made of silicon. And so when silicon is exposed to the sun, essentially the photons, or the particles of energy coming off of the sun in terms of sunlight, cause a separation of charges in that semiconductor, in those layers of silicon on the photovoltaic or the PV cell. And so we separate electrons from the protons, and then we get essentially a flow of electrons, which is exactly what electricity is just a flow of electrons. So when you have PV cells on a roof, they can directly power your building, but then if you're making essentially more energy than your building is requiring, you can send the excess energy that you've made back into the grid, and then that earns you a credit from your utility company. So you can kind of make money from your solar panels, if you will. All right. One of the drawbacks of solar panels is that they're intermittent, right? The sun's only out during the day. And if it's a really cloudy or a rainy day and the sun is not out, you're going to make minimal amounts of electricity from your solar panels. These problems, so that intermittency problem, can be solved through the use of batteries. So you could store that energy to be used later for days when it's not sunny or at night. But at this point, batteries to store energy from solar panels is really just, it's not cost effective at this point. Oh, I need to go back to this picture right here. So this picture right here is really important. We call it the duck chart, and it's this idea that these darker lines are fossil fuel usage. And so when we have solar panels, our fossil fuel usage for electricity is high during the early morning hours before it's light out. And then once it gets light, we see this huge dip in the fossil fuel usage because now we're relying on our solar panel usage during the day. But then as it starts to get dark, we see that we're ramping up our fossil fuel usage, and it actually exceeds what it was before because this is peak time at home, making dinner, that sort of thing before we go to bed, and it drops off again. So this idea that there's this crazy curve here makes the use of solar panels again a little bit tricky. All right, concentrated thermal or solar thermal energy, also known as concentrated solar power. This is basically this field of mirrors, or what we call heliostats, and they are surrounding this centralized tower. And so then we're going to concentrate these solar beams from these mirrors onto this tower again to heat water or some other kind of fluid to generate steam, to turn a turbine, to generate electricity, like we've been talking about with all of those other power sources. So one of the drawbacks of this is we usually find these in the desert, which isn't necessarily the most biodiverse or the most wonderful habitat, but it is habitat nonetheless. And if we put in all these heliostats, it is habitat destruction. Another interesting thing is that we're concentrating all these rays, all the sun's rays into this one small area. And so that's pretty intense heat. And so if birds fly through there, they can be fried midair. Probably not something that you're going to write on an FRQ, but interesting nonetheless. All right, so there's that idea. These heliostats concentrate the sun's energy on this solar receiver to heat this liquid, this hot molten salt or some other liquid, that brings it to a boiler to generate steam, to turn the turbine, to run a generator, to generate electricity. All right, when we're talking FRQs and solar panels, you need to differentiate between, are these rooftop solar panels that we might be using on an individual basis, or are these like a solar community or a large-scale solar farm? Because it's important to note the difference there, essentially. So larger scale solar farms can generate lots of electricity, but in doing so, they take up a lot of space and they can cause habitat destruction or fragmentation. Rooftop solar isn't going to take up a lot of land or a lot of space, but it's only going to produce a little bit of energy, enough to power your home, maybe. So we've talked about these kind of throughout, but just making sure that you've got a good sense of this. So solar energy pros, there are no air pollutants, no particulate matter, no sulfur dioxide, no nitrogen oxides released during electricity generation. And that's important to note, that it's during electricity generation. It does release some of those things as we mine for the silicon or the raw materials that we need to build those solar panels. So no carbon dioxide release when we're generating electricity. It is renewable, so it's not going to run out. And then we're not mining for fossil fuels for electricity production. We are mining for the materials to generate these solar panels, though, so they still need to be mined. And in doing that mining, we can disrupt habitats, we can pollute waterways from our mine tailing piles, and particulate matter into the air. Also, silicon's a limited resource, so when we use it all up, we've used it all up. It's not going to regenerate. And then, like we said a little while ago, solar panel farms can displace habitats or fragment habitats. So the FRQ that I'd like you to look at is to explain the relationship between the tracking ability of a solar PV system and its energy production. So kind of look at these, the way these PV things are faced, and then it's telling you tracking dual axis, single axis, etc. And so go ahead and answer that question for me, please.